Hello and welcome back to Calculus. First, you already know I'd like to thank all the nice people for supporting this channel by liking and subscribing. This video is a continuation of the previous one on integration by parts. Please recall, it is used when integrating two functions that are multiplied together. And we assume that one of these functions is going to be u while the other is v prime, in other words, v derivative. From the investigation, visualization, and calculation of the product rule for differentiation in the last video, we came to the conclusion that the result we get from this integral is going to be u times v minus the integral of v times u prime. The goal here is to get another integral that hopefully is going to be easier to solve. However, what happens in a case when we have definite integrals which also require integration by parts? Well, the idea is actually the same as definite integrals before, only this time we're going to have two different components because of the integration by parts. Thus meaning that for the first part where u is multiplied by v, we have to put the parentheses and the bounds of the integral. And then the following would be minus the integral once again from a to b of the remaining function v u prime dx. For the first part of your answer here, you can immediately plug in the bounds and compute the answer. And of course, for the second integral, you have to apply the fundamental theorem of calculus, which states that you have to find the antiderivative function of v times u prime. So basically solve the integral and then you plug in the respective bounds of the integral and calculate the final answer. Again, just like always, for definite integrals, the answer you're going to get should be a real number. The concept here is not difficult, so let's immediately take a look at an example. Let's say we're tasked with finding the value of the integral from 0 to pi over 2 of the function x squared times cosine x. It is extremely obvious that there are two smaller functions multiplied together, and thus we have to use integration by parts. So immediately, here I recognize that our u is going to be x squared. And then our v prime is going to be cosine of x. And immediately I can compute our v, the integral of cosine, which is just going to be sine of x. And then the u derivative, or u prime, is simply 2x. Now that I have all the four components, I can continue using the rule for integration by parts, which states we have to multiply u times v. In this case, that would be x squared times sine of x. Please do not forget that this part of our answer is also bounded by the bounds of the integral. And then we do minus the integral from 0 to pi over 2 of u prime times v. In our case, that would be 2x times sine of x dx. Here, many may be confused since the second integral that we got is not easier to compute. However, it is still made up of two functions multiplied together, which is 2x and sine of x. So that means that we do have to use integration by parts again, which can happen quite often. So again, our u is going to be 2x and v prime is going to be sine of x. Thus, our v is going to be negative cosine of x and our u prime is simply going to be 2. From this, I can keep writing the answer to the original integral. I simply copy the front part since it was untouched. Then I do the minus, and very important, please do write the big parentheses because a lot of signs are going to appear and you don't want to mix them up. Now expanding the second integral using integration by parts, what we're going to get is u times v, which is going to be negative 2x multiplied by cosine of x, and again minus the integral from 0 to pi over 2 of u prime times negative cosine x. So that's going to be 2 times negative cosine x, and please note that negative cosine carries a minus. Here, according to the rule of integration by parts, we have another minus, which means this becomes a plus, and what we have is simply 2 cosine of x dx. And now lastly, all we have to do is solve this integral right here. The answer we're going to get is simply 2 sine of x, and of course from 0 to pi over 2. For simplification, I opened these parentheses and rewrote these signs. Now all we have to do is simply calculate each part separately and then add and subtract all the results. For the front part, x squared sine of x from 0 to pi over 2, what we're going to get is pi squared over 4 times sine of pi over 2, which is just 1, and minus 0. For the second part of this answer, we have 2x cosine of x. When plugging in pi over 2 and 0 into this expression, what we get is simply 0. And lastly, when I plug in pi over 2 into 2 sine of x, what I get is simply 2. And 0 will give me 0. So the answer to the last part is just 2. This means the value of this integral is simply going to be pi squared over 4 and minus 2. If you'd like, of course, you can also write the answer as 1/4 times pi squared minus 8. Both answers are correct. They don't make a difference. And so this is how you evaluate integration by parts when you have a definite integral. In the next video, we're going to keep speaking about integration by parts, more specifically, cyclical integration by parts. So I hope to see you there and have a nice day. Bye.